In this video, let us discuss the properties of group 14 elements. Group 14 elements, they are also called carbon family because carbon is the first element of this group. So, you can also call them carbon family. And the elements of group 14 are carbon, silicon, germanium, tin and lead. Now let's write the symbol of these elements. Carbon, C, silicon, germanium, tin is Sn and lead is Pb. Now we know that carbon is in second period, third, fourth, 5 and 6th period. And in second period we know that the 3d orbital is or d orbital is absent, no d orbital. Now in third period we have vacant 3d orbital. In fourth period we have vacant 4d orbital, but we have filled 3d. Now fifth period we have vacant 5d orbital but filled 3d and 4d, and in sixth period we have vacant 6d orbital, whereas 3d, 4d, 5d and 4f orbital also filled in sixth period. Next, let us discuss about the electronic configuration. The general electronic configuration of group 14 elements is noble gas, NS2, NP2. So, the valence electrons present in group 14 elements is equal to 4 and their valency is also equal to 4. Now, let us try the electronic configuration of these elements. The electronic configuration, let us first write the noble gases. Carbon takes helium, neon, argon, krypton and xenon. Now carbon is in second period, so we have the outer configuration as 2s2, 2p2, 2s2, 2p2, 3s2, 3p2, 4s2, 4p2, 5s2, 5p2, 6s2, 6p2. So this is the electronic configuration of group 14 elements. Now let us discuss some questions based on group 14 elements. The first question is, the atomic or ionic radii of group 14 elements are smaller than group 13. We know that across the period atomic radius decreases, and we know the reason also because across the period the nuclear charge increases, the electrons are added to the same shell. So Z effective increases and atomic radius decreases. Now the next question is, there is a considerable increase in atomic radius from carbon to silicon down the group. There is an increase in radius from carbon to silicon, but from silicon to lead only a small increase is observed. So down the group atomic radius increases, but here you can say that from silicon to lead that increase in atomic radius is very small. Now what is the reason for that? It is due to poor shielding effect of completely filled d and f orbitals. You know that down the group when you come to lead, the d as well as f orbitals are getting filled. So due to poor shielding of d and f orbitals, the atomic radius, that decrease in atomic radius is very small. Now next, let us discuss about the oxidation state of group 14. So oxidation state of group 13, we saw they can show two oxidation state, and that oxidation state differ by a unit of 2. Same way group 14 elements also can show two oxidation state which differ by a unit of 2. So the oxidation states exhibited are +2 and +4. These are the two oxidation states exhibited by group 14 elements, and we know that down the group lower oxidation state is more stable. So +2 is more stable, down the group. And +4 is less stable down the group. And we know the reason for this difference in stability of oxidation state is due to inert pair effect. Now, next question is, the first ionization enthalpy of group 14 is higher than group 13. This is due to small size of group 14 elements and high Z effective of group 14 compared to group 13. Now, next question, carbon and silicon shows +4 oxidation state while other members show +2 oxidation state. Why? Because we know that carbon and silicon are the first elements of the group. So, for them higher oxidation state is more stable. So, they show +4 oxidation state, whereas the last elements, that is the other members, they show +2 oxidation state because of inert pair effect. And the last element is lead. Lead, the common oxidation state which is stable for lead is +2. Now, next question is, define the term catenation. We have learned in organic chemistry about catenation, especially carbon can show this property of catenation. Catenation means the self-linking property of carbon atom due to small size and high carbon-carbon bond strength. That is the reason for this catenation, and catenation tendency decreases down the group due to increase in atomic size. So, if you arrange these group 14 elements in decreasing order of their catenation property, we can write carbon, the catenation property of carbon greater than silicon, germanium greater than tin, greater than lead. Now, next, define allotropy. Allotropy. And what is the reason for allotropy? Now, allotropy means the existence of an element in 2 or more forms which have different physical properties but same chemical properties are called allotropy. And this is due to the property of catenation and pp bond formation. So, that is the reason for allotropy. And the 3 allotropes of carbon are diamond, graphite and fullerene. Diamond, graphite and fullerenes. These are the 3 allotropes of carbon. Now, next let us discuss the reaction of group 14 elements with oxygen. So, reaction with oxygen. Now, group 14 elements form 2 types of oxides. One is monoxide and the other is dioxide. And let us see the monoxides formed by group 14 elements. The monoxides are carbon forms carbon monoxide, silicon SiO, germanium GeO, tin SNO and lead PbO, out of which this carbon monoxide is a neutral oxide. SiO, this will exist only at high temperature. Now, germanium oxide is an acidic monoxide, and this tin and lead oxides both are amphoteric. Now, let us see the dioxides of group 14 elements. The dioxides are carbon dioxide, silicon dioxide, germanium dioxide, tin dioxide and PbO2, out of which this carbon, silicon and germanium dioxides are acidic in nature, and tin dioxide and lead dioxide, these two are amphoteric in nature. So, this is about the oxides of group 14 elements. Now, next let us see the reaction of group 14 elements with water. So, next is reaction with water. Now, carbon, silicon, germanium. These three will not react with water. So, no reaction with water. Whereas tin will react with steam. Steam means water in vapor state. Okay, it reacts with steam. So I am going to write the equation for the reaction of tin with steam, Sn plus 2H2O giving SnO2 plus 2H2, and lead, no reaction with water. Lead will not react with water due to the formation of a protective oxide layer. So, this is the reaction of group 14 elements with water. Now, let us see the reaction of group 14 with halogens. So, reaction with halogens. Now, group 14 elements form two types of halides, that is dihalide with general formula MX2 and tetrahalides with general formula MX4. Now, there is a question here. The stability of dihalides increases down the group. Now, dihalides means it has the general formula MX2. So, X halogen charge is -1, -1 into 2 is -2. So, the metal takes +2, and the question is stability of dihalides increases down the group. We know that down the group +2 oxidation state is more stable due to inert pair effect. So, dihalides are more stable down the group. Now, next let us see a question. Carbon forms only tetrahalides, whereas other members can form hexahalides. Carbon can form only tetrahalides. Other members can form hexahalides, means they can form 6 bonds, whereas carbon can form only 4 bonds. Now, what is the reason for that? The maximum covalency of carbon is 4 due to the absence of d orbital, whereas the other members can expand their covalency greater than 4. So, they can form hexahalides. Now, let us see the allotropes of carbon, that is diamond and graphite, and first let us discuss about the structure of diamond and graphite. So, next is the structure of diamond and graphite. Now, first we will discuss about the structure of diamond. Diamond has a crystalline lattice. So, diamond has a crystalline lattice, and in diamond each carbon atom undergoes sp3 hybridization, and it is linked to 4 other carbon atoms by a tetrahedral arrangement. Now, the Cc bond length in diamond, C single bond C bond length is 154 picometer, and the structure extends in space and produces a rigid 3-dimensional network of carbon atoms. So, we have a 3-dimensional network of carbon atoms in diamond, and the carbon atom is sp3 hybridized. Now, next let us see about graphite. Graphite has a layered structure. And these layers are held by van der Waals forces, and the distance between 2 layers is 340 picometer. Then the carbon-carbon bond length, Cc bond length is equal to 141.5 picometer, and each carbon atom undergoes sp2 hybridization, and it makes a hexagonal ring. Then each carbon makes 3 sigma bond with 3 neighboring carbon atom, and the 4th electron forms a pi bond, and the electrons that there are free electrons which can be delocalized over the whole sheet. So, this is about the structure of graphite, that is that has a layered structure with a hexagonal shape, and carbon is sp2 hybridized and Cc bond length is 141.5 picometer. There are free electrons which can be delocalized. Now, let us see a few questions based on diamond and graphite. First question is, diamond is covalent, yet it has high melting point. Why? In diamond, carbon atoms are tetrahedrally linked to 4 neighboring carbon through C single bond C. This forms a 3D network and makes diamond very hard and has high melting point. Now, next question, diamond is used as an abrasive for cutting glass. Abrasive. Due to 3D network structure, it is the hardest naturally occurring substance. Now, next, diamond is a bad conductor of electricity. Why? Because there are no free electrons in diamond for the conduction of electricity. Next, graphite is used as a lubricant. Why? Because it has a layered structure in which the different layers are held together by weak van der Waals force and can slip over one another. Next question, graphite is a good conductor of electricity. Why? In graphite, only 3 electrons of each carbon are used in making hexagonal ring. So, the 4th electron is free. Presence of this free and mobile electron makes it a good conductor. Now, next question, graphite is used for making electrodes in dry cell because graphite is a good conductor of electricity due to the presence of free electrons. So, these are the questions based on the properties of diamond and graphite. Now, if you are asked to differentiate between diamond and graphite, then I am going to give the differences. Diamond, carbon atoms in diamond are sp3 hybridized, whereas carbon atoms in graphite are sp2 hybridized. In diamond, it is formed by joining tetrahedral units by strong covalent bond with a 3D network of carbon atom, whereas graphite has a layered structure formed by joining hexagonal rings. Then, in diamond, each carbon is surrounded by 4 other carbon atoms. Graphite, each carbon surrounded by 3 other carbon atoms. Now, diamond has no free electron, carbon has free electrons. Next, diamond is a bad conductor of heat and electricity, carbon is a good conductor of heat and electricity. Next point, diamond is the hardest naturally occurring substance, whereas graphite is slippery and is used as a lubricant. Now, let us discuss some more questions from group 14. The question is, anhydrous aluminum chloride is used as a catalyst. Why? Aluminum chloride is an electron deficient compound and aluminum has only 6 electrons in the valence shell. So, it acts as a Lewis acid and can act as a catalyst. Now, the next question, a very important question. The question is, carbon dioxide is a gas, but silicon dioxide is solid. Why? Now, the answer is, due to small size and high electronegativity of carbon, it forms p-pi multiple bond with oxygen, and carbon dioxide molecules are held by weak van der Waals forces. But due to large size and low electronegativity of silicon, silicon cannot form p-pi multiple bond with oxygen. So, silicon forms single covalent bond with oxygen and it creates a 3D network. So, large amount of energy is required to break this. So, SiO2 has high melting point and it exists as a solid. Now, next question is, the +2 oxidation state of lead is more stable than +4. Why? Because of inert pair effect. Now, next question, PbCl4 is less stable than SnCl4. PbCl4 is less stable than SnCl4 because PbCl4, the oxidation state of lead is +4 in this, and we know lead is stable in +2 oxidation state because down the group the stability of lower oxidation state increases due to inert pair effect. Now, next question is, name the element of group 14 which is used as semiconductor. We have silicon and germanium which can be used as semiconductors. Now, the next question is, except CCl4, all other tetrahalides are easily hydrolyzed by water. Answer, in other members of group 14, they can accommodate the lone pair of water molecules in their vacant d orbital. But carbon does not contain vacant d orbital to accommodate the lone pair. So, they can undergo hydrolysis easily, the tetrahalides of silicon, etc. Now, when it undergoes hydrolysis, silicon tetrachloride, when it undergoes hydrolysis, we can write the reaction as SiCl4 plus H2O. We have two lone pairs on oxygen, and you can see HCl is removed and lone pair on oxygen will be taken by silicon. We get minus HCl, HCl is removed and we get silicon, chlorine, chlorine, OHCl. Now, we have 3 chlorine which can be replaced by OH group. So, we can show in the next step plus 3 H2O. Each step we can add water, and each step when you add water minus 3 HCl. HCl is removed, and the final product that you get after removing this HCl is all the chlorine gets replaced by OH group, and the name of this compound is silicic acid. Silicic acid. Now, the next question is, SiF6 minus is known, whereas SiCl6 minus is not. Now, you can see that the answer is fluorine and chlorine. Both are hexahalides, 6 fluorine and 6 chlorine we have, but fluorine is small in size. So, 6 large chloride ions cannot be accommodated around Si4 plus due to the small size. Okay. Also, interaction between the lone pair of chloride ion and Si4 plus is not very strong. So, this is the answer for this. Now, next we have the uses of carbon. The last point coming here in group 14 is uses of carbon. I will read out few uses of carbon. The first use is the crucibles. Crucibles made from graphite are inert to dilute acids and alkalis. Then, being highly porous, activated charcoal, all these are the allotropes of carbon. Activated charcoal is used in absorbing poisonous gases, also used in water filters to remove organic contaminators, and in air conditioning system to control odor. Also, being a good conductor, graphite is used for electrodes in batteries and industrial electrolysis. Then, graphite fibers embedded in plastic material form high strength lightweight composites. The composites are used in products such as tennis rackets, fishing rods, aircrafts, etc. So, these are the some of the important uses of carbon. So, with this we complete group 14 elements, the important properties and uses of group 14 elements. Thank you.